So here's a little something about the quotient rule for exponents and defining a number that's raised to the zero power. The first thing we'll look here is using the quotient rule for exponents. Now, if we want to simplify exponential expressions involving quotients, or we might say fractions, because we're talking about division, you may see something like, what if we have a fraction like x to the third power over x squared? Okay. So if we look at this, we can think we have a fundamental principle of fractions here. We can divide the numerator and denominator by common base factors, which means if we take this and write this as x times x times x, which is what we're doing, x cubed, and write the bottom as x times x. Well, if we think about this, then essentially what we're really looking at doing is we can factor these out. We can factor that x and that x and that x and that x, and all we have left is just x. And let me give another example before I get into what I want to talk about. Let's say we have x to the 7th over just x. Okay. Now we know this is x times x times x times x times x times x times x over x. So if we cancel one out each thing, what do we get? We get x to the 6th. But you should see something starting to develop here. Really, when we multiply, we talked about multiplication. X cubed, times x squared would be x to the 5th, because we add them. When we divide, we're just subtracting. So if we do have x to the 7th over x, that's the same as saying x to the 7th minus 1, because remember, this would be an exponent of 1 here. So here, the original one problem we started, x cubed, x squared. This would be the same as saying x to the 3rd minus 2. Okay, now, that being said, okay, basically we're looking at the quotient rule for exponents. It states that if we have, if m and n, again our m and n, are positive integers, and a is a real number, so a is a real number, and what this means, then anything a to the m over a to the n is the same as saying a m minus n. Okay. So basically, again, if we have something like x to the 6th over x to the 4th, that's the same as saying x to the 6th minus 4 x squared. So basically, if you think about it, what we're doing is if we bring, and I'm going to talk in non-mathematical terms here, if we were to bring this x to the 4th, let's say we just want to isolate it as a denominator. If we want to bring it up here, we can do that. It becomes x to the negative 4th. So really, when we think about this, when we have this x squared to x to the 4th, it's the same as x to the 6th. X to the 6th, well, there's a negative 4 that would be our exponent. Same thing happens if we have x squared over 1. We bring this down here, 1 over x to the negative 2 power. This is a little trick we use, and we'll talk about this in the next section with negative exponents. The quotient rule for exponents does state that if m and m are positive integers, and a is a real number, then a to the m over a to the n is equal to the a to the m minus n. Okay. Now, what about something raised to the 0 power? We haven't talked about that yet, but let's take a look at this since we're talking about quotients. Now we know if we have something like x to the 5th over x to the 4th, well, basically the same as x to the 5 minus 4, which is x to the 1st. But what if we have x to the 5th over x to the 5th, or x squared over x squared? Well, if we do that, we're thinking really x squared minus 2, which is x to the 0 power. And we know any number over itself is equal to 1. So basically what we're saying here is anything to the 0 power is 1. So we could take 1,426,832. We could take that to the 0 power. It's equal to 1. And the main reason why we have here the qualities that we have in the quotient rule for exponents is why this is true. So hopefully this helps with the quotient rule for exponents, and also with taking numbers to the 0 power and why we really look at them in that sense, and why anything to the 0 power is 1. Because if we looked at it in fraction form, anything over itself is equal to 1. So to have an instance where we have exponents and we have a 0, we would almost have to have something like x to the 4th over x to the 4th. And now we know that that's the same thing, so that's going to be equal to 1. So hopefully this illustrates anything to the 0 power and what we do with the quotient rule. We'll be getting into some negative exponents yet in scientific notation, so we'll see you in the next one. Have a good one. Bye.